All right, our last lesson of our first unit, we're talking about factoring higher order polynomials and working with some operations in our binomials and monomials. Our ICANs are learning targets. We can factor higher order polynomials. We're talking about degree 4 and greater. And I can perform multiple operations to simplify a polynomial. So our first learning target, our process is going to be to look for some structures of the difference of two perfect squares, sum and difference of two perfect cubes, and this thing called a quadratic form. And we're going to factor either using identity or the guess and check. And we should expect to factor multiple times when we have a higher degree polynomial. So the quadratic form is we have our leading term that has an even exponent. And then the middle term of this trinomial is exactly half of that leading exponent. And then we have a constant. So an example would be, we'd start with this, and if we expand it out, our trinomial of quadratic form would be 12x to the fourth, even exponent, plus 24x squared. 2 is half of 4, and then our constant. So we check this is of quadratic form because we've got a 4 and a 2 and a constant. And so we're going to break this up. Same rules apply. This is a plus sign, so both of these operators are the same, and we look to that middle term to figure out what they are. But instead of writing an x and an x, we're writing an x squared and an x squared. And now we need factors of 100 that add to 29. Well, that would be 25 and 4. Now here we've got some more work to do. We're not finished like when we factor a second degree trinomial. Here we've got a difference of two perfect squares and another difference of two perfect squares. So here we have an x and an x and a 2 and a 2, and one has a plus and one has a minus. We have an x and a 5 and a 5. One has a plus and one has a minus. And then all of these factors are linear, so we have achieved the prime factorization, or we have fully factored that trinomial. Here again, we have that same quadratic form, even, half of that leading exponent constant. We'll take x to the 8th as x to the 4th, x to the 4th, and factors of 18 that would add to 7 would be minus 9 and plus 2. Now this first one here, we're not going to do anything else with. 2 is prime and the plus sign means that it's prime. But this difference of two perfect squares, we can factor some more. We can take the x to the 4th and make it x squared, and take the 9 and have a 3 and a 3. One has a plus and one has a minus. Here again, we have another quadratic form, 6 and 3, and our constant. Here we've got to do some thinking, some guess and checking. 7 is pretty self-explanatory. The only factors of 7 are 7 in itself, because 7 is one of our prime numbers. But 32, we can factor that as 32 and 1, 16 and 2, or 4 and 8. And we have to have one plus and one minus, and the net that we have to get out of that combination of that leading coefficient and then our 7 is to end up with 52x squared. And so if we use the 4 and the 8, we'd have our 56 minus 4, which would give us 52. This one is prime, it's plus. This one is our difference of two perfect cubes that we did yesterday. So we use our SOAP. We take 2x and a 1, do the same operator. Then we put the leftovers 4x squared and a plus 1, always positive, and then we multiply these two together and put the opposite sign. Here we don't have one that's of quadratic form. It is higher order because this is a 6 exponent, but here we have that structure of no middle term, just our leading term and our constant with a subtraction. So we're going to divide the 6 in half with a 3 and a 3. And then we'll take the square root of 64, which is a perfect square, and put 8 and 8. Now both of these can be factored. We have the difference of two perfect cubes and the sum of two perfect cubes. So we'll do the difference first. An x and a 2 and a minus, an x squared, a plus 4, and a plus 2x. Now we'll do x cubed plus 3. We have an x plus a 2, an x squared, plus a 4, but now we have a minus 2x as our linear, our middle term. And as we talked about yesterday, those trinomials never factor anymore. Right now we'll do some operations. We'll use our PEMDAS, our parentheses, exponents, multiplication, division, addition, and subtraction. So the first operation we would do here is multiplication. We'd multiply these two binomials, and then we're going to combine some like terms, and then we'll factor out the greatest common factor of a y. Here we'd do the multiplication first. We distribute the 3 to both of these terms. We combine some like terms, and then we take out the greatest common factor. Here we do our multiplication first. That's our special product, our a squared plus 2ab plus b squared. Then we would distribute the minus or subtract both of those terms to get negative 2x plus a 12. And now we have to combine some like terms. So I have 1x squared plus 10x's plus 48. So we have to think about factors of 48, both being positive, that add to 10. And you can see none of these factor pairs will do that. So this one does not factor. Again, we're going to do distributing that 2x to the x and to the 3. We're going to distribute that minus 5 to the x and to the minus 2, ending up with 2x squared plus 6x minus 5x plus 10. We'll combine some like terms. And again, we're looking at 2 and 1, 10 and 1, and 2 and 5, both having the same positive sign. There's no way we're going to get that to add to just 1. So this does not factor any further. Right, there are some for you to try, so you'll want to do that. Maybe pause the video, do that, and check to make sure that you are getting the same result that I am. If you're not, then make sure you sign yourself up for Compass for Thursday, because we will be able to have Compass before your you have this class.